and for this session tonight, and we're going to talk today about testing and inspection of fire alarm system. This is the first in a series of building safety webcasts that we intend to be putting on, where we're going to be focusing on different areas of the NFPA codes and standards and talking about topics on how to increase fire safety and how to design systems that are more efficient and that meet NFPA standards. As you already can tell, since you're logged on to the webcast, we're delivering all the audio and the video for the webcast session through this GoToMeeting session. And you're going to use headphones or speakers to hear the audio, and you'll need a microphone to ask questions. Everybody is going to be muted during the call to help cut down on background noise. But if you have a question, you can use the raise hand button on your webcast controls, or you can, if you'd rather, go ahead, you can type your questions into the questions panes. That way we'll have written questions that we can respond to, and if we see your hand up, that we'll know you have a question, and at the end of the session, we'll be able to go through those and unmute you and have a conversation with you. What we'd like to do is we'd like to save the questions to the end of the presentation. The idea here is that we'll be, this is a 90-minute planned session, and the idea is that we'll do about 60 minutes on content, and then we'll leave a good 30 minutes at the end for questions. Whenever we get into codes and standards and interpretations and things, you know, there's always a lot of really good, healthy discussion, and you know, we certainly want to make sure that we're available for plenty of time to go through those. So, with that being said, we'll switch to the content of tonight's session. And again, like I mentioned earlier, we'll be looking at the need to inspect and test fire alarm systems, and then how inspection and testing requirements relate to the NFPA codes, and what the NFPA codes say about testing and inspection, and what has to be done to keep your systems in compliance. Then, after we talk about codes, we'll give you a look at some of the new technologies and new products that are on the market that are geared at making testing and inspection and installation easier, simpler, faster, and help you keep your systems to be more reliable and in good working order. And then finally, at the end, we'll give you a peek at some of the remote service solutions that we have in place in Tyco, and that we're starting to really build on those capabilities with new products coming down the development path. So, to introduce you to who we are and who's speaking with you tonight, first of all, this is me. My name is Peter Ryan, and I'm a commercialization manager for Simplex products. What that means is I'm on the marketing side, and I work with our product development groups to launch products around the world, and I also work with them to gather customer needs and information so that we can build those things into the new products that we're developing. My specific areas of focus are Simplex brand products in the Middle East and Asia Pacific regions. So I do a lot of traveling, and I do a lot of spend a lot of times with customers and representatives in those regions. I've been here for Tyco about 18 years in the fire alarm industry, and primarily have been a marketing manager and a product manager, and worked on corporate communications. The person who I'm really thrilled to introduce to you today, and who will be presenting most of the NFPA session, is Roger Reiswig. Roger is our Director of Industry Relations, and he's been with Tyco for over 27 years. Roger has a ton of experience and industry knowledge, and he also is on a whole number of NFPA, NEMA, National Electrical Manufacturers Association, Automatic Fire Alarm Association committees, etc. Roger is on the committees that play an instrumental part in writing and updating standards, and he also has been on these committees for several years, so he has just a tremendous amount of knowledge about why the codes are the way they are today, the interpretation of those codes, and where those codes are going in the future. So I'm really thrilled that Roger is here tonight and having a chance to speak with you. And again, he's a absolutely perfect person to ask questions to as well. So again, he's here for both of us are here to conduct a session and to share our knowledge with you. So with that, I'm going to go ahead and I'm going to turn the presentation over to Roger, and Roger's going to start talking about the codes and standards. And there
Yeah,
you
so
go.
good day, everyone. And I'll go ahead and
Yeah.
change this to,
We see your screen.
okay.
Perfect.
All right. So we'll go ahead and talk about, why we test fire alarm systems and the governing documents for this. NFPA 72 is the document that we use for testing fire alarm systems, finding what the requirements are. I deal a lot with NFPA 72. I sit on a couple of chapters on 72. I'm on the Supervising Station Committee, Chapter 26, how signals are sent off-site. And I'm also on the new Chapter 24. Well, I say new, kind of the old Chapter 24 now for emergency communication systems. All voice communication systems and mass notification fall under it. And then there's a overall encompassing committee called a correlating committee that makes sure that one committee doesn't overstep their bounds or intrude on another committee. So I spend a lot of time with 72. Everything we're going to go through today is going to be on the 2013 edition. The 2016 edition, this document, like many NFPA documents, goes through a 3-year cycle. So the 2016 edition is finished, and it will be published the end of September, beginning of October, somewhere around that time frame. So it won't be that long until it's on the street. But for today, everything that we're going to go through is going to be from the 2013 edition. So our testing chapter comes from Chapter 14, and in Chapter 14, it is the only chapter that's retroactive, meaning that no matter when your facility was built and what edition of 72 and the Life Safety Code it was under at the time, whatever edition of 72 has been adopted today, that's the edition you use for testing and inspection. It's the only chapter that's retroactive. The rest of the document is not, unless local jurisdiction, codes, governing bodies require that. So we'll just jump right in. Why do we test fire alarm in systems? Well, in 72, we say at least every device must be checked annually. We got to make sure that at least everything in our system works, and we're going to physically verify that at least once a year. Some things take multiple times to test, but we want at least every component tested once every 12 months. And with life safety systems, we don't always know if they're fully operational just looking at them. We walk by them sometimes and we see the green lights lit and we think everything's okay, and usually it is. But with electronic components, things degrade over time. Dirt and dust can contaminate our detectors, and maybe we had vandalism or there was remodeling, renovation that maybe moved the device or covered it up or something. So we need to do a visual inspection as well as a functional inspection of our equipment, our devices, because we want to make sure that our system is going to work and it's reliable. It's going to work when we call upon it to work. Hopefully you have a fire alarm system and it never works, right? We never want to have a fire, and we hope that we never do, and never have a situation where it's called upon. But in the unfortunate event, if something does happen, we want it to be there for us. So we inspect our systems and we maintain them, and we want to really improve our reliability of our systems by testing them periodically and going in and exercising them and making them run through their paces, and all the equipment works. It helps us to ensure the reliability being that it's going to work when it's called upon, when we need it. And with proper maintenance, one of the other things that we try to combat in the industry is to reduce false alarms, or what we call in NFPA 72, nuisance alarms or unwanted alarms. As smoke detectors, for example, as they get dirty, it might take a less and less amount of smoke to activate them, and they could potentially cause a nuisance alarm for us. So with good maintenance and servicing of our systems in conjunction with testing, we can help to reduce those nuisance alarms. And then for the owner, the contractor, the person, the distributor, the dealer, the person that's actually doing the work, we also want to decrease the risk and the liability. We don't want anybody to get hurt in any of our buildings that we have out there. And if our fire alarm systems can be reliable and they don't have the false alarms or nuisance alarms, it helps for the people to have confidence in the system, rather than, yeah, it's the fire alarm, it's going off again, you know, we're not going to respond to that, it's just another false alarm. We don't want that. We don't want that sense of apathy, we call it, in our structures. So lack of maintenance and testing is the leading cause of failures of our systems. And this is just a couple of pictures that I found over my travels. Like Peter, I travel a lot as well and spend a lot of time in hotels. On the picture on the left, it shows the smoke detector hanging down, and you talk to the maintenance people, and they tell you, yes, we had the ceiling worked on, we had it painted, and that detector's been down, and we've never put it back up, or for some reason. But the device may not function properly if it's not mounted correctly. Here it's just a few inches below the ceiling, so it probably would work, but we want to make sure that it's secure and it's in place the way that the device was intended to operate. And then the picture on the right, it's kind of a comical picture, where somebody says, yeah, I exercised the valve and I made sure that it closed and opened properly, at least once a year, no problem. But here we have branches that are growing from the tree through the valve, and obviously nobody has turned that valve in a long time. And Peter pointed out to me that it's even growing through the chain there a little bit, that nobody's gone in and exercised that. So we want to make sure that the stuff is going to work, our equipment is going to work when it's called upon, and when we need it to. And like with any electronic component, electronics are going to fail over time, and fire alarm is no different. Even though Peter and his team make great products, and the components themselves, the capacitors and various IC chips, they can degrade or maybe not function as they should over a period of time. So we kind of ran out a mean time between failure analysis, and we used 4 failures per million hours as a maximum design failure rate that can be permitted. And so what does that really mean to us when it comes to what we call rubber hits the road, or when we're actually in the fields? What does that really mean to us? So if we take and let's lessen it for the numbering to work out a little bit easier, let's use 3.5 failures per million hours of use. So if we take all the systems that are installed in the world and we say, okay, for every 3.5 failures, we're going to have 3.5 failures per million hours of use. So that means 3% of our detectors, for example, will fail in a year. So 3% of all the devices in the field will malfunction for one reason or another. And if you extrapolate that, we're at 26% will fail in 10 years, 45% in 20 years, and 60% in 30 years. And working with our dealers, some of our branch district offices, these numbers add up pretty consistent with how we are doing our inspections and the amount of devices that we're replacing in our systems. So, and again, a lot of these, the functionality of the smoke detector, for example, you really wouldn't know if it failed without testing it, without doing a functional test. So, and that's what we want to do. We want to make sure that our devices are going to work. So it's kind of a good way here. This is a good exercise to kind of just show what we're talking about. 26% of our smoke detectors are going to fail in 10 years, and that's about what we run into in the industry. So let me look at how long does the building last, how long does the fire alarm system last. With Peter, we've talked before that fire alarm systems in many cases are lasting 25, 30, maybe even longer, in 30 years in a building. And so it's not uncommon for systems to be in for several decades. So when we talk about inspection, testing, and maintenance, that all comes from Chapter 14. So NFPA 72, for those that don't know, it's divided up into chapters, and we have different chapters for different parts of the document. We have the initiating device chapter, we have notification appliances, we have fundamentals, how our power supplies operate, battery backup, and so forth. So Chapter 14 is the designated chapter for inspection, testing, and maintenance, or we call it ITM. So in the document, you'll see things, in all NFPA documents, you'll see how it's designated as 14.2.2.2, for example, in the first section. So 14 will always reference the chapter that it's in, and then the .2.2.2 in this case is the actual section. So we're going to go through these, and I have the references there for you as we go along. So in 14.2.2.2, we have impairments and deficiencies, and this was kind of one that we didn't really have in 72 for Well, we never really had it in there. We always told you had to test the building fire alarm system and note anything that didn't function. But we never really came out and told you you needed to fix it. So in 14.2.2.2 in 2013, we modified it to say, system deficiencies shall be corrected. So you might sit back and scratch your head and say, yeah, that kind of just makes sense. But it was never really in the document. So whenever I find something that's changed in the document, I always ask why. What was the driver to change that? Something had to cause it to change. Typically on the committees, we don't just change things to change them. Something must have triggered it for us. And then we say, if not corrected at the time of the conclusion of the inspection, after we're finished doing everything, if I don't have the part on my truck or I need to order it, it's going to take some time to get it in, or the owner maybe doesn't want to pay for it right now. If it's not fixed at the time of my inspection's completion, then I've got to notify the owner in writing within 24 hours of what deficiencies that we found. Now the owner is able, and we spell this out in 14.2.3.2, this is a new section also, that the owner has the ability to delegate the responsibility to somebody maybe on site or some representative that's an occupant of the facility. Because it's not uncommon for us today to have buildings that are owned by companies or conglomerates that might reside in another country, let alone in another area of a country. So it might be difficult for me as an installer, maintainer, to try to track down that owner. Why can't the owner designate somebody in one of his office buildings or tenants of a mall or something that I could go to? So in 14.2.3.2, it allows the owner to do that. It gives them the ability to designate responsibility, be the owner's rep, if you will. Something that's also new in 72 is a test plan. It's important for us to understand what we're going to test and what we're not going to test. And what I mean by that is there have been issues in the past where an inspection company gave a report to a building owner, and in it said they tested all the smoke detectors in the elevator lobby. And maybe the technician said, I also verified that elevator recall worked. Well, the building owner, and this was a real case that actually happened, not with Tyco, but with another company, that the building owner thought, well, gee, you wrote down here that you tested the elevator recall, so I don't need to call the elevator people to come in to do their inspection, excuse me, because you already took care of that for me. Well, no, that's not what we did. We just verified that the relays worked for the elevator recall. Well, that's not what your report says. So you kind of understand, write a test plan, tell me what you're going to test, tell me what you're not going to test, and provide that in your documented inspection records for the building owner. Some formatting was cleaned up. For those of you that are familiar with 72, we had a separate table for testing methodology and the testing frequencies. So we combined those together in 14.4.3.2 into one table. Makes it a little bit easier for the owner or for the reader to understand or follow what's going on. With voice intelligibility, up until the 2010 cycle, so back in 2002, 2007, we required voice intelligibility measurements to be done, meaning somebody had to go out there with a meter, verify or predict how good the system is for its intelligibility. We've always worried about or tried to strive to make sure that we hit the audibility mark with our fire alarm systems. 15 dB above ambient or something like that to make sure it was loud enough. But it wasn't until relatively recent past code cycles that we really started to care also about intelligibility. So it's great you can hear what's being said across the speakers, but can you understand what's being said through the speakers? So now we have both audibility and intelligibility. And for those of you that might not be familiar with an intelligibility, Annex D in the back of 72 is a great document that speaks about how do we design for intelligibility, what is intelligibility, how do we test for it, and what's permissible in our testing of our systems. So NXD is a really good document to review. It's about 15 pages or so it's not a heavy read. And then we say, when we go into a facility, we need to have some kind of a sign or something to alert people to let them know as the occupants are coming in and out of the building for the day if the system is going to be tested and what's going on. So this is an example where somebody took one of those big signs, put them up on a little easel or A-frame and stuck them in the lobby or by the elevators to let people know that on October 15th from 9 o'clock to 15:30, we're going to go ahead and test the fire alarm system. So if you hear anything, you know to ignore that. And a lot of people do this. They'll put notes under the doors or tape things to the windows. But this was one part that we don't see people doing a lot. It's in 14.242. And we say at the conclusion of the testing, those that were previously notified shall be notified that testing has been concluded. So what we mean by that, if I could just go back a slide, if you come into the building and you know that the fire alarm is going to be tested starting at 9 o'clock and it's going to be tested all the way through until the afternoon at 15:30, so you're prepared for that. If the fire alarm goes off, you know that they're just testing and you go about your regular business. But maybe we got done a little early. Maybe we got done at 12 o'clock and we didn't need to stay on until 15:30. So we put the building fire alarm system back into service. Everything's great, and we get our record signed and we leave and everything's done. But at 1:30, there's a real fire and the fire alarm goes off. Well, if we didn't inform the occupants that we were finished, they would naturally assume it's still in its testing phase. So, and this actually happened in a few situations. So we added this section in 14.2.4.2 to say you need to tell people that when you're finished, that you're done, and anything further from then on, they need to treat as a real event. So when we look at fire alarm systems, we talk about reliability. Is it going to work when we need it to work? So we say for reliability, it must be properly designed, meaning if we have an outside area like this, I don't know if you can see my mouse, but there's an audio-visual unit right here. Is that enough of an audio-visual unit to get the people's attention in all of these rooms? Is it the right device to have outside? So we got to make sure our devices our systems are properly designed before they're even installed. We can negate a lot of nuisance alarms or problematic situations by having a system that's properly designed. So in 72, for 2000 and actually in 2010, we really worked hard on the qualifications of who was able to work on systems, who was able to design systems, program them, etc. So those all reside in the fundamentals chapter. So chapter 10 in this case is fundamentals chapter, and we talk about the system designer. So in 10.5.1.1, we say that the fire alarm system and emergency communication systems plans and specifications shall be developed in accordance with this code by persons who are experienced in the proper design, application, installation, and testing of the systems. And what we mean by that is this is for maybe the authority having jurisdiction or the engineer, where you're looking at a person's design and you're just scratching your head saying there's no way that this person understands fire alarm systems. This has to be the first one they've ever done. Let's ask that person for their qualifications. How do we know that you're qualified to design a system? So where do I find that? Well, that's in 10.5.1.3 and .4. And we talk about, first off, in 5.1.3, the system designer shall be identified on the system design documents. When I unroll those floor plan, the blueprints for my fire alarm system, and I look at my title block, it needs to be identified on there who's the system designer, not just that it was Simplex or Peter Ryan's fire alarm company. It needs to tell me who the person was that did that. Further, we can request the designer to provide evidence. How are you qualified to do this system? What credentials do you have? So we listed a few things here that could comply. Number one, and it's not all of these, it's any one of these. So they're not all inclusive, it's just any one of these would suffice to meet the requirements. So number one, personnel who are registered, licensed, or certified by the state, the country, the the local authority, civil defense or what have you. Could be number 2, a person who is certified by a nationally recognized certification organization. There are several of those throughout the globe that do a series of testing and then can issue certificates to people in recognition of their skills. And then we have another one here that, for example, Simplex, Tyco could help to supply personnel who are factory trained and certified for the fire alarm system design and or emergency communication of the specific brand and type. So any of those ways would comply, but if you're a civil defense or an engineer or a building owner, this is where you can use the section to ask somebody, what are your credentials, how are you able to design this and give me proof that you know what you're doing. Well, what are you talking about? Well, in 10.5.1.4, it specifically states you need to have one of these certifications or credentials to do it. So we also, continuing with that thought process, we talk about a fire alarm system to be reliable, it also must be properly installed. So we can have the best design, right? We can sit down, design it the best way we can, and have the optimal system on paper. But when it comes to putting it in, did they follow what we told them to do? Did they put it in correctly? And this is a little bit of an older picture, but it really drives the point home, where we have an exit light, an emergency exit light, we have emergency lighting, and then we have an audio-visual unit that is blocked by the exit light and the emergency lighting, and then the smoke detector there on top of it. So, so this was, yes, they're installed, they're at the right heights or what have you, but they're not going to function the way they were intended, the way that the devices are arranged there. So it's the same thing as we have with Designer. In 10.5.2.1, again, the fundamentals chapter, we say that fire alarm systems and emergency communication systems installation personnel shall also be qualified or supervised by persons who are qualified. And it's the same type of process that we had for Designer. Are you registered or licensed by the state or the local authority or the civil defense? Have you gone through a series of testing from some nationally recognized testing laboratory or organization? Or are you factory trained and certified by an entity like Simplex product? And again, this is to ensure that the people that are installing our systems are competent. They understand what's going on, and we can ask for proof in 10.5.2.2. And then again, for fire alarm systems to be reliable, they also must be properly maintained. So we can have the best design, we can have the best installation, but if we don't maintain it properly, the system is going to fail on us probably rather quickly. So here's just a couple of pictures that we have. This one was a picture I took in a facility, and I had asked about the tape that they had over the smoke detectors, and it was in the back of house, and somebody had said that that tape has been on there for a long time because it's been years since the ceiling was painted. Well, nobody bothered to go in and take the tape off, much less the person that was doing the inspection year after year didn't notice that it was full of tape, so the device wasn't even being tested properly. And then a picture on the right, this one was, Peter found this one, where somebody took a rubber glove and stuck it over top of a smoke detector. Not the exact best way to protect the device, but somebody did that. And then obviously left it like that, and there's no way that smoke's going to penetrate into that chamber to alert us that we have a situation developing. So as I talked about earlier, we talk about we want to reduce as much as we can our nuisance alarms, or sometimes what people would call false alarms. We try not to use the term false alarm. We try to use unwanted alarm or nuisance alarm or something like that. But people sometimes don't leave a building when the alarm sounds because they don't always believe that it's a real fire alarm, especially if it's gone off a lot over the course of months or even years. They just don't trust it anymore or don't believe that it's real. And a lot of people, if they don't see flames or smell smoke, people assume that it must be a false alarm or a nuisance alarm. You know, and we've all witnessed that. The fire alarm goes off and people start looking around and they start smelling, and if I don't see flames or smell smoke, then it must not be real, so I can just stay where I am. And that's not the right thing to do either. So within 72, as I was saying earlier, we talk about false alarms or nuisance alarms. And we really want to stop using the terminology false alarm. We want to start using terminologies that can really help to better define what happened, rather than classifying everything as a false alarm. So we came up with some new definitions. Chapter 3 in the 3.3.307, Chapter 3 is our definitions chapter, and then definition number 3.307. And we have unwanted alarm, any alarm that occurs that is not a result of a potentially hazardous condition. And we have malicious alarm, or an unwanted activation of an alarm initiating device caused by a person acting with malice. Nuisance alarm, an unwanted activation of a signal or an alarm initiating device in response to a stimulus or condition. And then we have unintentional alarm, an unwanted activation of alarm in a building caused by a person that wasn't trying to do it with malice. So an unwanted alarm it's just an alarm that occurred in our system, and we don't want it to happen. But then we divide it up into malicious. Somebody that was going out maybe as act of vandalism or mischievousness and was trying to cause panic in the building or what have you, and they intentionally activated the system. We have nuisance alarm. Nuisance alarm could be, we know why it's going off. We know that it's too close to the ovens, and whenever they open the oven up, it always sends out this burst of smoke from whenever they burn bread, and it causes the device to go into alarm. So it would be a nuisance alarm. Then we have unintentional. I'm welding today. I really didn't think it was going to set the system off. I'm really sorry, but it was an unintentional. It was an accident, if you will. And then we have unknown. Unknown's kind of our last one, where we say we don't really know why it went off. It probably is a bad device, or it could be maybe where it's located. We're just not quite sure. But between the four of those, we can really start to define now what type of nuisance alarm or unwanted alarm that we have, and not just classify everything as false alarms. Excuse me. So why do we test and inspect systems? Well, we have the Life Safety Code, NFPA 101, and we also have the model codes, the I codes, the International Code Council series. And both of those are pretty heavily used in the throughout the globe. Or there's a derivative, or countries will modify them and then adopt them as their own standards. But they're pretty much the staples in the industry, or the leaders of for building codes. And building code, for example, let me just back up. Building code tells us when to put something in. A building standard tells us how to do it. So our building codes, like NFPA 101 or the I codes, are going to say, in this occupancy, you shall put in a fire alarm system, but you're going to install it per NFPA 72, or a sprinkler system per NFPA 13, and so forth. So a code tells us when to do it, a standard tells us how to do it. So in NFPA 101, for example, this is the charging section that gets us to 72. So in Chapter 9, Section 613, a fire alarm system required for life safety shall be tested, inspected, shall be installed, tested, and maintained in accordance with the applicable requirements of the electrical code and 72. So that drives us and gets us into the 72 world. And the same with the I codes. There's language where it says an approved fire alarm system shall be provided in accordance with this section. An approved automatic fire detection system shall be installed in accordance with 72. So typically that's the language that we see in the building codes that gets us to 72. So NFPA 72 on its own, really it doesn't do anything for us. And people will often ask Peter and I, well, where in 72 does it tell me I have to install a fire alarm system? It doesn't. The occupancy code with the various occupancy types, business, educational, what have you, that's going to tell us when a system needs to be installed and what needs to be installed. So as we go through this, what are some of the problems that we find in our systems? Well, one is detectors are installed before construction is completed. And that's not always great, because the devices can become maybe painted or contaminated with dust or dirt or what have you. And we say in NFPA 72, because this has been a problem for us over the years in the industry, we say that where detection is not required during construction, the detectors themselves shall not be installed until after all other construction trades have completed the cleanup. We don't want the dust and the debris and the dirt going through the air and getting inside of our smoke detectors. So we tell you that you shouldn't install those. So if anybody challenges you and say, well, where does it say that in 72? Well, chapter 17, so it'll be 17, section 7.1.11.3 specifically states. So what about ambient conditions that may cause us this nuisance alarms that we're talking about? Well, again, in chapter 17, we talk about spaces that are served by air handlers. The detectors shall not be located where airflow prevents operation of the detectors. So this is an example of that. Hopefully you can see my mouse moving there. And as we have air coming out of the diffuser, it goes along, skims along the ceiling. And by doing that, if we had a fire and smoke started to rise, the air coming out of this diffuser would push that smoke away from the detector, and it would probably keep it from operating. The other thing that it would do is this air flowing every day would probably cause a buildup of dirt on our smoke detector as well, possibly causing nuisance alarms from our system. So where does it say that the detectors can't be close to the airflow? In 17.741. And then if you notice there's an asterisk next to the 1. Whenever you see an asterisk next to a section like this, that means in the back of the book in the annex there's more explanatory information about this particular section. It gives you a really good glimpse at what the committee was thinking when they wrote this section. What did they really mean by this? So the asterisk to that then becomes A.17.741. And in the annexes are not enforceable. They're not written to be code language or enforceable code language. So in A17.741 we say detectors should, rather than shall, detectors should not be located in direct airflow or closer than 910 millimeter from an air supply diffuser or a return air opening. Now this was a picture that I had just as an example of the people that are doing construction and work. And the detectors should not be installed, but you can see they're wearing masks to keep the dust and dirt out of their bodies, and you can see the haze that's in the rooms. And we just don't want that going into our smoke detectors in our facilities. Excuse me. We talk about detectors being located adjacent to showers or a bathroom where you open the door up and the steam, the water vapor can come out of the maybe a hot shower and cause the activation of a device. So in 72, in chapter 29, we talk about smoke alarms and smoke detectors shall not be installed within 910 millimeter of the horizontal path from a door to a bathroom containing a shower or tub unless it's listed for that proximity. So that's in chapter 29, single and multiple station alarms and household fire alarm systems. Chapter 29, 834. And just to go back, so this is what we're looking at. You can't be closer than 910 millimeter from the door, because as that steam would roll out, we don't want that steam to go into the head and activate the device. So 29834 provides guidance on that. So some of the electronic service tools that we have in the industry to help us combat or to do our jobs better maybe. One has to do with automated testing. And this was something we added into the code a couple of cycles ago, and we're seeing it in NFPA 10 for extinguishing systems, fire extinguishers, portables. We see it in NFPA 25 for the inspections of sprinkler systems, and we also see it here in 72 for fire alarm systems. And basically this allows the green light, if you will, for the manufacturers of the world to start to create devices they can start to test themselves. So in chapter 14, section 2.7, we have automated testing. So we say that automated testing, that it's arranged that can provide equivalent means of testing devices to those specified in the table. So we say if you can come up with a test that basically does the same functionality as somebody going to the device and testing it, we'll accept that. And then we continue to say, at a frequency at least equivalent to those specified in table 14.4.5. So we say if the device needs to be tested monthly, then your automated testing needs to do it at least monthly as well. And your automated testing needs to perform just as though somebody went and actually physically tested the functionality of the device. And then the final part of that is in 14.2.7.2, if the failure of a device on an automated test shall result in an audible and visible trouble signal at the fire alarm control unit. So if you can do those three things, you can declare your device to have automated testing. Fire extinguisher maintenance, for example, is another area where we have automated testing can come into play. You know, our extinguishers are portable devices. They're required to have monthly physical inspections of the extinguisher. We need to go to the extinguisher and verify that the pressure is correct, the device is not blocked, and the device is there. It's on the wall, mounted securely, and ready in case somebody needs it. You know, we've done some surveys, some research, you know, and just the first bullet there, 24% of extinguishers inspected annually are not in the proper location. They're either not there, they're not mounted correctly, not there ready to be used. 26% of extinguishers inspected annually are inoperable due to low pressure. They don't have the right amount of pressure. Maybe somebody activated it by accident or something happened to it. So what we're talking about with that is, with electronic monitoring, there's now equipment that's available that can have a module that can sit next to the extinguisher, and the module has ultrasonic sounder in it that can send out a pulse once every few hours and look for a return of that pulse to verify that nothing's blocking the extinguisher. And then we have a wire that goes up and connects to the back of the gauge. It's a quick release wire, so if somebody needs to use the extinguisher, they can grab the extinguisher, pull it off the wall, and then it disconnect itself from the wire. So we know that the device is present. And then the wire also interfaces with the gauge on the device, and we can know that the device has the proper amount of pressure that it requires. So if I can do those three things at least once a month, like I'm doing a functional test, and if it fails, I enunciate that at the fire alarm system, I can deem this an automated test of my system. And we do that. And there's thousands of installations that have this installed as an example. So it's another way that automated testing has come on the scene. Extinguisher monitoring is prevalent in the codes. It's in the I codes all the way back from 2006. The 2007 editions of NFPA 10, which is the document for portable fire extinguishers, and 2007 edition of 72, all acknowledge this or allow this to happen. So it's a way that technology is allowed now to be able to be used to test our systems and make them more reliable. We talk about easy of service by design. And one of the things that we've come up with, and maybe Peter, if you want to jump in and speak about this a little bit, but we have our new audiovisual ES line.
Yes, certainly, Roger. I'd be happy to. So, Roger's in the material that we've covered so far, Roger's done a really good job talking about the codes and standards and the requirements for testing and so forth. And I think he's made a very good case for why things need to be tested. But what we recognize and what we've seen in the just around the world is that while people have good intentions and people want their systems to work properly, depending on how it's designed or how it's built or just the physical layout of the system in the facility, it can be very difficult to test everything. So what we are trying to do with the Simplex products, and you'll see over several of these slides coming here that we're going to talk about, is you have the code requirements now, but let's make products that make it really easy and simple and fast and just quick to test the appliances and the devices inside the facility, because the easier it is to test, the more likely it's going to be tested, and the more likely things are tested and the more often things are tested, the safer you're all going to be. So the code is sort of the we have the carrot and the stick saying we have here in the U.S. The code is sort of the stick that makes you requires you to meet these particular criteria, but the carrot here is now let's give you some products that make it easy for you to do that. So one of the latest things that we've released, which really does make testing a lot easier and a lot more revolutionary, some functionality in these products, is our True Alert ES family of appliances, notification appliances, visual, audio visual, and audio only. And what these appliances have is a light sensor and an audio sensor built into them. So Roger was talking before about the self-testing. And that code allows us to actually use those transducers inside the product to test them, whether they've flashed and whether they've made a sound. So back at the panel, you can either manually initiate a test or you can program the test to happen automatically, and it fires off those devices and then it tells you whether or not they work properly. And that's all without a technician having to go to each one of the devices. The key is that not only can you test your appliances in seconds and test your whole facility in seconds, but if you think about occupancies like a hotel or like a hospital, or even a casino, where it's very difficult to test the appliances because you need access to those rooms when there's nobody in them or you're not going to disrupt anybody. So this notification appliance design, the True Alert ES, makes it a lot simpler to target the appliances and to test them when it's not going to be disruptive to anybody. So this is a feature we're quite proud of because we think and we see that this is going to lead to a lot safer systems and a lot more easily tested systems. So if we go on to the next slide, Roger. Another key feature of the Simplex products is, well, I'll say there's actually two things we'll talk about here, is both what we call the drift compensation of the detectors and the way we put the electronics to have the sensor, the electronics for the sensor in the base and the addressing for the sensor in the base. So first off, what drift compensation does, it allows the detector, as it gets dirty, to change the range of the detection capabilities so that we always maintain the same level of sensitivity in the detector. As dirt or dust or particles can collect inside the detector, the sensitivity levels and the thresholds are automatically adjusted by the panel so that we maintain the same performance out of the detector. So first of all, this is going to help cut false alarms or nuisance alarms because the dirt is going to be having less of an impact on the performance of the detector. The other side of it is that as this threshold moves, it allows the detectors to tell the panel, hey, I'm kind of dirty and I think I need someone to come out here and clean me, or I'm going to not perform anymore, or I'm really dirty and I really do need someone to come out here and clean me, all the way up to, hey, I'm so full of dirt and dust that I'm just not operating anymore, and I'm going to put the system into trouble until someone goes ahead and cleans me out. So that's some logic built into the system that maintains performance, but that also helps ensure that that you know when you need to take care of those detectors in the field. The right-hand paragraph is interesting in the sense that it talks about the NFPA 72 calculations 14422, and what that essentially says is that for a detector to pass the UL listing process, it needs to be calibrated, and we need to prove to UL that we're operating at certain temperatures, at certain thresholds, and with the sensitivity requirements. So the UL listing required to get that NFPA 72, all of our detectors meet that, and then the performance of the drift compensation helps ensure that they stay operating properly. Roger, I didn't know if you had anything you wanted to add there?
No, it's a great point, and the device is able to do that. And with the drift compensation, as Peter had said, it ensures that the device, tries to ensure that the device will not false alarm or have a nuisance alarm based on dirt. So by giving you these messages and giving it to you clearly.
Right. So if you go to the next slide, another thing that product that we released recently is called the XAD Duct Detector. And if you flip to the next slide, Roger, What this really is trying to solve some problems that we've seen with duct detectors. Now, if you're familiar with duct detectors, you know where they're going to be installed. You see them in hospitals and large manufacturing facilities, basically anywhere where there's air handling units. You know, a lot of air conditioning, a lot of air, being forced through the facility and ventilation. Next slide. So we have a standard duct detector, which is seen in this picture if you click one more time, Roger. And essentially the standard garden variety duct detector is pictured there up on the whole assembly there. And we see and we have hear from our customers a lot of negative feedback on not just our products but duct detectors in general. Because they're installed on the duct, they're difficult to get to. Sometimes they require a scissor lift or a cherry picker to get up there. Sometimes they get put on the channel on the ducts and then they get obscured by work that's done later, or other trades come in and put pipes and things around them. And we have customers who have duct detectors in trouble because they haven't been tested or cleaned, and they physically can't find them in their building. They have lost the duct detectors, if you can believe it. So duct detectors are a real headache for a lot of the customers and a lot of the installations. So again, if it's hard to service and you can't find it, that just makes this all very difficult to adhere to these codes, and it all makes it very difficult to ensure your system's running properly. So we looked at that and we said, how's there a better way? What can we do to modify the product to make this better for our customers? And that's where we came up with the idea for an XAD. The XAD detector was developed in concert with Xtralis, who's a leader in aspirating detectors. And what this basically does is it allows you to put the sampling points and the exhaust point of the detector up into the ductwork that you need to sample at, but you use rigid tube or flexible tube to hook those probes back to the actual duct detector housing where the sampling is being done. And because this is an aspirating detector, it has a fan inside of it and it's actively drawing air down those tubes. So it's sucking air from the sampling tube, running it through the detector, and then returning it through the exhaust tube. What that means is, in addition to the operation, what it means is that the duct detector itself can vary the speed of the fan inside there to account for the types of flow that go through that tube. So if you have a system that shuts down periodically and there's no airflow through the tube, the duct detector will still operate because it's still actively drawing air through the sampling tube. And just likely, if you have, when the airflow turns back on, the duct detector can adjust its force to accommodate for that. So you're always going to get positive airflow and you're always going to get positive sampling of this duct detector. So why is this interesting? Well, if you have the sampling tubes up on the ceiling where that old duct detector would go, you use those pipes to connect it to the electronics. The electronics can be mounted down on a wall where you can get at them. So your duct detector now becomes something that you can walk up to and calibrate and service and test without having to get on a ladder, without having to crawl up into the ceiling or get a scissor lift and waste time and energy and maybe have safety issues as well. So the XAD certainly doesn't replace all duct detectors in every instance, but when you have hard to reach ones, the XAD is a really good solution to make things easier to test. Next slide, Roger. Just a couple quick comments here on the XAD. There's an example there of how simple it is to put smoke into it. Essentially, you pop the cover off of the detector housing and you inject canned smoke into it, and it'll give you an alarm to make sure that the system is working properly. And there's also a filter on there to try to keep dust and debris out of the XAD. There's also an optional water trap that can be installed on the unit. So if you have an environment with a lot of humidity and condensation, that water trap will actually allow the water and the moisture to condense out and drain off before it gets into the XAD, so that you don't have any component corrosion problems. That's another common issue with duct detectors, is because of where they get put. They frequently get corrosion and humidity and condensation and all those things that aren't good for anything that's electronic. So another key point there to keep it working and make it easier to service. Okay. Do you want to do this part, Roger?
Yeah, for remote service options that we have available, or some of the things that we're seeing in the marketplace, as Peter was talking about with the XAD, the remote access makes it easier to maintain. If it's easier to maintain and people can walk up to it and do a functional test, they're more apt to do it and keep their nuisance alarms or unwanted alarms at bay. And like Peter was saying, I really like this device because it always is pulling air from the ductwork to sample it. And whether the duct is operating or not, this device will be able to pick up any smoke that's in the air. With conventional duct detector, if the HVAC system is down, then the duct detector is kind of useless at that point. And then the life cycle cost, as we look at this, we have less disruptions, we eliminate the lift rentals, and fire brigade response, and downtime, et cetera, as Peter was talking about. So there's a lot of savings, but also increases the reliability of our systems. So with our electronic systems, what we're able to also start to do now is have the fire alarm system send information or have information available via a web portal. It can act like a website. It can send you emails or text messages, a lot of different ways to get information out to customers. But this is a way that we're doing, looking at systems to see, well, how many of the systems that are tied into my campus, for example, how many fire alarms do I have? How many supervisory conditions do I have and troubles? And based on that, we can start to formulate potential risk, or how we can monitor how at risk we might be with our fire alarm system. We have an activity report that we can run. We can look at our profiles and understand what's going on. And with our systems tied into the web portal, you can actually interrogate the cards, the power supplies, the communication cards to the peripherals in the field, the smoke detectors, the duct detectors, what have you. And as you see here, you can see what the system voltages are, the current, how the batteries are functioning, how much power are they using from the charger. And then down at the bottom, we can even see individual devices. Device number 116 that's in the bookstore. What value will it go into alarm? What's its average value? And we can use these things to start to formulate hypothesis of anywhere that we might have a problematic situation occur before it occurs. And some of the things we're looking in the future for maybe some larger customers or dealer network might be to have a quick glance from a graphical point of view on where are all of my systems installed, which ones maybe are clear, which ones have maybe troubles on them, which ones have alarms, and to get an understanding of what's going on. And maybe if I had to dispatch repairmen or first responders, we would have that available as well, looking through these dashboards. And one of Peter's favorites is actually even putting this thing all the way out to not just your tablets, but your cell phones, your mobile devices, where you can see all of this information in your hand pretty much no matter where you are in the globe.
Right, and I think that's something really important to take away from the discussion here, is that just like the rest of your life, the other areas of your life where you have your smartphone, your Android or Apple iPhone, and you're putting apps on it and you're expecting, everybody now basically expects that device in their hand to be able to connect and to get them whatever information that they want wherever they are at any time of day. So the thought here is that the fire alarm panel has a lot of really good information and is a critical piece of building infrastructure. And instead of having it just be a box on the wall that makes noise at you when something bad happens, we're more and more, and this isn't just Tyco, this is, I think, all manufacturers, they're more and more bringing the internet and bringing connectivity capabilities and leveraging those to the fire alarm system. So we're looking to get all of our panels hooked to the internet and to be able to enable that communication. So just like Roger said, you can have your iPhone and you can run an app on your iPhone, and you can connect to your system. You can get notified when there's troubles. You can get notified when there's alarms. You can look at the status of the system from wherever you are. And then the remote service model that Roger showed in the previous slide. The idea there is that you're going to, and we're running a pilot, I'll call it, with our sister company Simplex Grinnell in America here in the US. But the idea is that those panels are hooked to the internet, and then they are communicating back to a monitoring station here that isn't monitoring it for alarms necessary, but is monitoring the health of the system. So when something happens with the system, either something goes into trouble or whatever, that information is relayed to technicians who use these dashboards to look at the condition of the system and try to diagnose and what's happening in that system. So the model before of a customer, the typical model of a customer seeing the red light on the panel or yellow light on the panel for trouble and going to the panel and seeing what's happening and then calling a technician and having that technician drive out to figure out what's wrong with the panel. We want to turn that around so that the panel calls the technician and tells them what's wrong with it, and that problem can be diagnosed so that when the technician comes on site, they know what it is, we've sent the right person to do that project, to do that service, and they brought the right parts with them. So we call it the old model was a dispatch to diagnose, meaning you send somebody out there to figure what's happening. Now we're going to diagnose before we dispatch and have a better first-time hit rate, first-time incident resolution. So information on your phones, information through the internet, email, SMS, remote dashboards, connectivity, it's all coming. And this is the future of the development for the panel and making it a dynamic part of your information infrastructure so that you always know what's happening with your fire alarm system. And that's where we're going, and it's pretty exciting. So I think you want to do the next one?
Yeah, so electronic inspection reporting, this is kind of the big thing I see in the industry next is it's great that we can do all of this stuff. We can test the systems automatically in some respects. We have these tools to generate reports, but how can I assimilate all this together and make it code compliant? And there's a lot of talk in the industry about how to make that electronic inspection reporting available, make it web-based maybe, or allow civil defense to see it, or a building owner that has multiple properties. But there's also a lot of discussion on keeping that secure, because I don't want just anybody to be able to see maybe how my systems are laid out or where the devices are and how they function, because they might use that as an act of aggression against my facility or to take out actions against us. So, that's one of the nuances that we're really trying to wrestle with in the industry within NFPA. But we're looking for ways, and we have ways that can provide for scanning our devices, whether it's using infrared or barcoding to scan every device. And the device doesn't have to be a smart device, if you will. It could be as simple as in our second picture here, where we have the picture of the spare sprinkler heads that is required to be on site. And you can go in and interrogate that and open it up and verify that they're all there, grab the barcode underneath, scan it to your device, and acknowledge that, yes, the box is still there, and yes, all the heads that need to be there for replacements are the right kind and they're ready to go. And then we can use this information also to guide our people or the dealers that are out there working on the systems through their inspections. What devices were tested last time. We don't want to test the same devices if it's maybe split up into 50%. Sometimes we take a system and we'll want to visit the facility twice a year, but we don't need to check all of the devices twice a year. So we'll use this to maybe help guide the inspector on which devices need to be inspected at this time, and also give more information about maybe where they are. As Peter talked about, some devices sometimes are hidden and they're not always just obvious there for us to go get them. And we also want to account for all the devices. If you have 50 smoke detectors, we want to make sure we check 50 devices when we go out there. And then provide all of this information very clearly to the owner, to the civil defense, and give it to them electronically, where we can be emailed or go up to a web-based portal where it can be easily retrieved, and maybe even use that data to start to run reports, where if a building owner wants to know how many systems do I have in total, Well, how many smoke detectors is that across all of my facilities? You know, knowing that you told me that 26% of my smoke detectors are going to fail in 10 years, and based on how many devices that I have in total, you can start to run reports and maybe start to budget monies to replace those devices or what have you. But it's all about improving the tracking of the equipment that's on site, consistent reporting, knowing year after year what we have, what was inspected, how it was inspected, what failed. It's all code compliance, and then streamline that, make it easier for the owner to use. And yeah, and just another point here, it does not replace testing. This is just a way to record what's going on to make it easier to capture the data that we're gaining while we're out there, and then offering it up to the owner of civil defense when they need it easily. Peter, you want to talk about the website?
Sure. So the main resource, let's say, or one of the easiest resources for you to use to get more information about Simplex products is our new products website. At that address there, www.simplex-fire.com. On that website, you'll see information about all of our products. We also have an architects and engineers section of the site that has a wealth of information and some handy design tools and tools to help you write specifications. All of our data sheets for all of our products are available through that website, and there's two ways to look at them. You can either use an index that keeps them, that has them organized into simple categories, or you can actually download what we call our Engineers Technical Reference Manual, which is a PDF file, but it has all of our data sheets for all of our active products, and then you can print them and put them in a binder, because a lot of people still like to, work with paper. So that, in addition to some specification templates that we have, some Revit files, Revit family files for BIM users, and a couple other tools in there, I think will make that worth your while and to visit. And we'll be adding new materials to that as well. So it's a good place to go, and I highly encourage you to add that to your favorites and to use it as a resource. So with that, we finished the formal part of the presentation. It's a little bit over an hour. And here on the screen, first of all, the contact information for Roger and for me. Certainly do take those emails down, those phone numbers down. Drop us an email, give us a call with any questions. We're more than happy to speak with you and to help out in whatever way we can. And like I said before, Roger is certainly a fantastic resources on codes and can really share some experience with you on that. So from here, I'd like to open it up for questions. Again, you can use the question box to type your questions in, or now you can also raise your hand, and if I see a raised hand, then I can unmute your line, and you can ask your question verbally. So. We certainly welcome you and invite you to ask any questions that you have. We did have a couple come in, and I'll just throw those out while we're waiting to see if any more. Roger, you mentioned earlier in the presentation that you were getting close to finishing up 2016 and the 2016 version of NFPA. Can you just highlight briefly what the changes we can expect in that and what might be of real interest to designers?
Yeah, in the 2016 edition of 72, we kind of look at that on the committee level as more of a maintenance mode. There wasn't any there's not a lot of dramatic changes, if you will, within 2016 that we've done. Off the top of my head, I'm trying to think of some of the major things. There was a lot of cleaning up of the language. The document underwent a major rewrite for 2010. And then we fixed a lot of things that we broke, if you will, in 2013. So we stepped back again for 2016 and said, okay, what do we really need to work on? One of the big things that did come out of that was a documentation chapter. A new chapter was created for documentation in chapter 7, which started out in 2013 and really culminated together for 2016. Anything to do with your tables for inspection testing forms, anything to do with the paperwork that's required for fire alarm systems, all now is housed in this new Chapter 7. There's a lot of other little things like that, but that's probably the big stuff, Peter.
Okay, great. Thanks, Roger. We have someone with their hand up, so I'm going to go ahead and unmute your line. This is Himanshu Yadav. You've been unmuted. Do you have a question? Himanshu, can you hear us? Oh, okay. He asked it. Let's see. I'll mute back his line. All right. Let me break the question pane out here so I can read it. My eyes are getting bad, Roger. I'm getting old. Okay. He's asking, due to complex building designs, it sometimes becomes difficult for remote access and monitoring. His comment. And I think that's a fair point. What we see is we see the systems becoming more complex and larger, so we're always increasing the capacities of our products. We see that especially in Asia and the Middle East, where they're building, very huge, very nice new buildings and campuses. It's a constant challenge to bring all that information back to one place, whether it be a single management console, and then to share that through a remote service type of capability. So that's something that that we are always looking at, and we're working to develop. So you have these TrueSight workstations, what we call them in the Simplex line, but you have these graphical management consoles that concentrate all the information and can put literally hundreds of panels on a single screen for you to manage. And we have, universities, for example, here in the U.S. that are monitoring 200, 300, etc. buildings all in one console. But then we take that information and we hook it back through the remote service capability to that centralized service monitoring team that we're testing out here in the US. So that lets them look at the service needs, and to react from that remote team can react to that and help the local office that provides the parts and equipment really take care of these products in a much more efficient way. So it's really sort of how all these things mesh together to help the customer and help keep the system running properly. So again, more internet, more connectivity, more wireless, more phone support. It's really, everything that we're working on now. I would really say is probably got some sort of connectivity aspect to it, or remote connectivity capability. Whether for service or performance in it, it's the focus of everything that we're really going to do. I don't know if you wanted to add anything to that, Roger. I know it's a key thing from the industry, and I know you're looking at, the way the codes deal with that.
Yeah, it is. And then along with that, too, is we're always trying to be cognizant of the fact that we want to keep data secure. Just because we're able to put things out on the internet or the cloud, we want to make sure that the right people are getting access to that and stays out of the hands of the wrong people. So we wrestle with that a lot too, which is sometimes why technology might lag behind a little bit in the fire alarm life safety arena, because it's one thing if maybe your phone gets hacked or doesn't function properly, if a virus gets on it or something like that. But if your fire alarm life safety system gets hacked or gets a virus, it's a whole different animal. So so it's the other thing that we really try to we're working with in this world today.
Yeah, security is absolutely, no matter what you do, security is a big concern for everybody. We have a good question here from Amrith. It is in a power plant. They have detectors installed that are always showing fault due to smoke and dirt, and how to avoid that. That's a very good, challenging environment question. We've seen some similar issues in transportation centers. We have very big installations in subways, and that's a very challenging environment as well. So you want to comment to that, Roger?
Yeah, as soon as you brought that up, immediately I went to the mind of the that air aspirating device. Like you showed we had for our duct detectors, we offer that in the industry. That's offered on a much larger scale, where you can have sampling tubes or piping that goes out throughout your room or area or facility, and it can actually pull air back to the filtered detector, and it can detect smoke and not be as more immune to dirt and dust like a smoke detector typically can't. So in a lot of these facilities, in the coal mines or hazardous plants or chemical plants where there's a lot of dust and debris, dirt, whatever going through the atmosphere, we'll oftentimes not even put detection out there, smoke detectors, but we'll use the air aspirating detectors. And then there's also some other detectors that are available, like beam detectors. We'll utilize those sometimes, or a UVIR, ultraviolet or infrared flame detector. If we see a little bit of a spark or anything, it can detect those. So there's technology options that are definitely available.
Okay, thanks, Roger. Yeah, that's always, like I said, we see that in, also, I cover a big pieces of the Middle East for my area of responsibility, and when they get, there's a lot of dust, especially in the lobbies and atriums. We see that too, from the sand and the dust that gets airborne in some of those places, and that's where also the drift compensation that I talked about earlier is very important, because that allows the detector to to operate properly for longer, but also that it's going to tell you that it needs to be cleaned. So the point detectors, that's an important thing to do, but like Roger said, sometimes an alternate technology is just a better way to go. A good question here, I think we've seen this one before, Roger, is someone's working on a design for a cold room. It's Mahendra Singh is asking the question, do you have any special types of detectors for working in a cold room to temperatures near -5°C?
Yeah, that's another tricky application for us. We get down to cold temperatures like that, our smoke detectors just won't function. And typically UL, Underwriters Laboratory, won't allow us to go below 32 degrees Fahrenheit or 0°C. So they won't even allow us to test for below that extreme area. And again, I don't want to keep pulling the same device out all the time, but our air aspirating device is another perfect application for that, where it can take that colder air, pull it out, and run it into a device that's outside of that cold environment and sample it and tell if there's any smoke or anything contaminants in the air. And so we use that a lot in these large freezer applications. I've also seen people that would be able to take a piece of glass that's kind of fog resistant and put a beam detector on the outside of the glass and shoot it through the cold area to the reflector on the other side, and they would use that for detection in those cold environments.
Great, thanks, Roger. Again, just looking at some of the other questions that come in. This is an interesting comment, again, from Himanshu, and I think he's talking to the inspections, and he says, fire alarms and extinguishers require manual human intervention for periodic inspections, but things can sometimes get missed. And what type of MIS systems or information systems can be used to identify the products and make sure that they're properly maintained on the right schedule?
Yeah, that's a real good point, and that we would go back to our electronic reporting system, where we have if we know that all the devices, or what all the devices are in the system, the quantities, where they're located, and we can put them into our database, then we can start to query or run reports based on what we've inspected and maybe what we've missed, to ensure that all the devices are accounted for and taken care of every year. So, so that would be probably the main thing that I would drive you to, is our data collection method with a barcode reader or what have you, to get the information into the system, and then use the reporting from that, either web-based or email-based or what have you.
Yeah, and just to follow up on that a little bit, I talked about the TrueAlert ES appliances and their self-test capability. Now, granted, those are the notification appliances, the strobes and the horns, but when they're tested, they report back to the panel, and the panel keeps the log of when they were tested and what the test results were. So you can basically go to the panel and get those reports out so that you can use those to show when they're tested and which ones need service and may need to be looked at. It doesn't replace the manual requirement for testing, the annual manual requirement for testing, but it allows you to keep those devices going all year without having to physically go to them.
Yeah, great point.
The follow-up question was about the XAD that we've mentioned a few times. Just if you could provide some commentary on the design of the pipe, how you would use it in an open area like a factory where you're doing point sampling instead of having it in an actual duct.
Yeah, and for a lot of those, there is a, well, for the Bethesda system or Extralis, they have programs that you need to really utilize, and you put in how large your area of your room is, how high the ceiling is, the type of environment that you have, and what you're looking to sample for, meaning how much smoke do you want to know about before it goes into alarm. And all of that goes into a program. They call it the Aspire program. And based on that, it will tell you this is how long your sampling tubes need to be. This is how far apart the holes need to be drilled in the sampling tube. And this is the size holes that you need to have. And they account for, they call it the transport time, on how long it takes for air to go from the sampling tube all the way back to the unit. And all of this is accounted for in their program. And it's actually very sophisticated, the Aspire program that they have to do that. Other manufacturers that have air aspirating devices do the same thing, as far as you have to do some kind of a calculation method to get to that point. But you can use rigid conduit for that sampling tube, and then just drill holes in it based on what the Aspire program points out. Or there's also PVC. Blaze Master is an example where it's fire-resistant PVC that you're able to utilize also. So it actually becomes very inexpensive to put the sampling points in, and it's just the electronics all the way back at the head end where it's actually monitoring or looking at the air that it's bringing back to it on a continuous basis.
Okay, great. So that's the Extralis. Is that some software that they can get from the Extralis site? Is it something that can be downloaded?
You can. There's a little bit to it, and there may be a class you need to sit through or go through, but I'm pretty sure that you're able to download that if you're a dealer from Extralis.
Okay.
There's also, if you go to YouTube, there's some nice videos where people have gone through and will just walk you through how they've developed or designed an air aspiration system using the Aspire program.
Great. And now Mahendra Singh is followed up the question on the cold storage area with a question about detection, the proper detection we should use for process lines where there's heavy steam. Sounds like definitely a heavy manufacturing environment.
Yeah, with heavy steam, exactly. So you're not going to want to use regular detection in those areas. And so again, I'd fall back to something like a UVIR flame detector. There's also a lot of work has been done with video image detection, or VID. It was something that was added into 72, NFPA 72 a few cycles ago. Basically, we're taking a camera and we're looking at an area or a shaft or something, and the software that actually looks at the picture continuously, it has very, very good algorithms built in that can discriminate between steam and smoke, somebody even welding as opposed to a real fire. It's just amazing what these video image detectors can do nowadays compared to just a few years ago. So that's also become a good alternative of detection types. And then while we're talking about processing areas, dust becomes a big issue for us where we have maybe a paper mill or some area or some processing that has very fine particles in the air, that the least little bit of a spark can set off all of those particles in the air, those airborne particles, and can create basically an explosion. So again, we want to look at something like a UV-IR detector that can let us know of the quickest little flame or spark that might be activated out there in the chamber or the facility.
Just out of curiosity, for an environment like that, what would there be any applicability or potential for using either a heat detector or a heat with in combination with a CO base?
Yeah, if we don't have too much of a worry on the material itself, like if it's a paper mill and we got a lot of dust of little pulp of paper going through, and it really is just the steam that we need to overcome, then I would definitely look at maybe heat detection or a combination where we have heat detectors and carbon monoxide. Carbon monoxide is unburned fuel, so if we know that we have a little bit of unburned fuel in the air and it's over a certain temperature, it must be a fire, and we'll go into alarm based on that. There's also some other products on the market. Protector wire is one of the ones that come to mind, where it's like a linear heat detector, where basically you have two conductors in a treated cable, and when the temperature gets to 135 degree, 155 degree Fahrenheit, it causes the insulation inside that wire to actually melt and allows the two conductors to touch. And the wire that is all then connected back to a head-end unit, and the unit is very sophisticated, and it can tell how far out the electricity has traveled and where it's shorted together and where it came back, and it can give you an indication of how many meters away from the control unit you are to where the actual event has taken place, or the heat event has taken place. So yeah, the good call, Peter. There is options with heat detection that could be used too.
Great. Thanks, Roger. And I'm just looking, just one last question here I see in the list is actually I think just for some comments about the 520 hertz for the sleeping area. That was something that was brought into the 2010 edition, correct? And could you speak just just briefly on what it could mean, and depending on where you're installing it?
Sure. In 2000, going back a few years before 2010 cycle, that's when it was added to the code. But some research was conducted in Australia, and they were finding that people in single-family homes were perishing, and they had working smoke alarms in their homes or apartments. And some people that were able to escape were testifying that they never heard the device. So, and there's a lot to this, but I'll try and make it short. What the research then bared out was people that are older, elderly, and people that are young, maybe 13, 14 years old and younger, have a hard time disseminating the high frequency tone, or even being able to pick up a high frequency tone. Our typical sounders that we use in the industry, and that's everybody, whether it's Honeywell or Siemens or Simplex or Wheelock, whoever it is, when we look at those piezoelectric horns, they're all at about the 3,000 to 3,300 hertz frequency range. And we do it with piezoelectric crystal. We put the crystal up side by side, ignite a little bit of electricity, they start to reverberate a little bit and create that high-pitched frequency. Well, the older people and the younger people aren't able to pick that up. They're not able to hear it. So based on that, NFPA 72 said we have to do something about this. And research bared out that lower frequency tones actually dramatically increase the effectiveness of awakening people awakening people that were asleep, obviously. So the optimal range seemed to come in at the 520 hertz plus or minus 10% area. So based on that, NFPA 72 incorporated into Chapter 18, the Notification Appliance chapter, that in areas where we know that people are asleep, our fire alarm system has to produce a low frequency sound to awaken those people. So I have to put in a low frequency sounder, for example, in my hotels, where I need to have 15 dB above ambient at the pillow. I need to also have a low frequency 15 dB above ambient to alert that occupant. So that's where this low frequency has come from. We're going to talk more about this, I think, on October 1st, if anybody would like to sign on. One of our companies, CWSI, Commercial Wireless Systems, is putting together a webinar on low frequency sounders, why we have it, and some of the products that we've come out with to be able to install that. And I'll actually be speaking a whole lot more on the low frequency component on that webinar, and that will take place on October 1st.
And I can, thanks, Roger, and I can certainly share the information with the attendees here after the webcast is over, and I'll certainly do that. What we'll also do is we'll get together some Q&As, and we'll follow up with that as well. So I know we're running just a little bit over time here, and I want to be respectful of your day, but there's 3 questions here, and I think we can that I think are good ones, and I want to just hit these real quick before we wrap up. So one of them is, can the fire alarm panel be integrated with cellular GSM modems, which can transmit messages and alarms on the cellular device?
Yeah, great question. In our supervising station chapter 26, we now allow, well, for several cycles now, allow GSM radio to be able to be used to send signals off-site. And when we talk about cellular or mobile communications with GSM, there's really 2 ways about that. The one that's commonly used is where we send basically, it's a crude way of saying it, but it gets the point across very easily. When we use GSM to send text messages, if you will, from our fire alarm control units to the supervising stations. The other way that's not as commonly used is where we use the cellular connection, the GSM connection, to actually use it to make a phone call where we incorporate frequency shift keying to send a signal off-site. So I just bring that up because sometimes people, when they say GSM or they talk about radios, we need to define exactly what we're referring to. But in Chapter 26, we allow that GSM radio. We also allow IP communicators. We have thousands of IP communicators going back to our supervising stations around the globe, where it basically just ties into the cloud and it just sends an IP data packet to the supervising station to let us know what's going on. Now, when you start to use these type of technologies, our supervision rate needs to be increased dramatically over what we've had conventionally with digital alarm communicating transmitters, or DACs, with telephone lines. With the old telephone lines, we said, oh, we need to test signals once every 24 hours. With an IP communicator or GSM, now all of a sudden we're looking at a test signal to be sent once every 5 minutes for 2010 edition of code, and once every 60 minutes for the 2013 edition of the code. So it absolutely can be used, but there's just a couple of precautions we just need to watch out for as we implement that.
Great. And one other comment I'll make on top of that is if you have an internet connection to the panel, so the panel connects either to the infrastructure, the internet infrastructure, the LAN infrastructure inside your building. We have 2 options. We have one thing called a SafeLink card, which allows an individual panel to be connected, and actually it will email or SMS text message you information about the panel. So if there's an alarm or a trouble or an event, it can reach out to you. If you have a large network system and you're monitoring all those from a central command console called our TrueSight Workstation Central Command Console, that TSW can be set up to send emails for your entire system. So there's a single panel solution if you're connected in a multiple panel solution as well to get that information out to you. And then I think the last question here is I think a specific one, but it's an interesting one. I think Dory is asking, what type of detection do you use to protect hydrogen gas tanks in an industrial application?
That would depend, what kind of tanks we're looking at. Definitely there's hydrogen gas detectors that are available. One of my favorite gas detection manufacturers is Draeger. Draeger makes a really nice unit that you install one base, but you can snap in about 22 different types of gas detectors into that base. So whether you want to detect ammonia, chlorine, hydrogen, and the list just seems to go on and on with Draeger. But I really like that company and how they've arranged their products to do that. And then again, based on the hydrogen with the high explosive content, and if I have a tank farm, if you will, I would still look at either video image detection and or coupled it with spark detectors or UVIR detectors to see if anything's going on out in those plants. So I hope that helps answer your question.
Yeah, thanks, Roger. I think it does. So again, I'm looking at the time here, and it's well, 12:36 a.m. in our time, so it's actually tomorrow for us. And I think this is a good spot to wrap it up. I have collected all of the questions here that were submitted via the interface, and we're going to look to put those together in an FAQ document so we can answer the ones that we haven't gotten all the way through for the session. And like I mentioned before, you're certainly welcome to send any of your questions to either Roger or me or both of us via email. That'd be just fine as well. So I thank you for taking time out of your day to spend with us during the session and to learn some more about the NFPA and the installation and service testing capabilities and code requirements. I hope we hear from you, and like I said at the beginning of the session, we will be doing these, probably every 8 weeks or so. I think every couple of months is a good pace, and we're just going to pick different topics and spend some time on them. So if you have topics that you're interested in or specific things you'd like us to delve into, like testing or like some of the detector spacing requirements, really anything, let us know. And we certainly, if we get enough demand, can make sure that we're covering what you're asking for. So with that, again, I want to thank you very much for spending your time. I hope you have an excellent rest of your day, and that we'll have a chance to talk to you again sometime soon. Thank you.
Thank you, everyone. Good day.